We will learn how to solve equations in trigonometric functions. You must first make a difference in your mind between the inverse function and solving an equation. For example, if I told you solve this equation and I told you find this value, what is the difference between these two concepts? This one gives me one value. If I told you x is equal to square root of 4, this gives me just one value, which is the positive 2. The square root is a function, and any function has only one output to a single input. Okay? But what about this? If I told you solve this equation, what is meant by solving an equation? It means to find all the values of x which satisfy this equation. Okay, so in this case I need to find all the values that satisfy the equation. Okay, in this case the solutions of the equation are written in terms of the inverse function. Okay, so the inverse function is just a single solution of the equation, but there may be some other solutions. These other solutions are described in terms of the inverse function. Okay, so that's why the solution of this equation, for example, is x is equal to plus or minus square root of 4. Plus or minus square root of 4. You may notice that the solutions, the other solution, there is one solution which is the inverse. This is one solution, but we need to find all other solutions. We will find that other solutions are described in terms of the inverse function, which is the other solution. In this case is the negative of the inverse function. In this case it is the negative of the inverse function. And so that is what we will study today about solving equations in trigonometric functions. We will solve three types of equations. We will solve if sine x is equal to a given number, alpha for example, or cosine, let's start with cosine. Cosine x equals some number alpha, or sine x equals some number alpha, or tan x equal to some number alpha. We need to find all solutions. There is one trivial or known solution which is the inverse. For example, one solution of this is cosine inverse of alpha. One solution of this is sine inverse of alpha. One solution of this is tan inverse of alpha. But this is one solution only. I need to find all solutions. I need to find all solutions of the equation. How would we find that? Now, any of these equations have infinite number of solutions. If we sketch the cosine x we have known is sketched like that. Okay, so if I need to know when would that cosine will be equal to alpha, some number alpha, this is alpha for example, we will find infinitely many angles that satisfy this equation. All of these angles satisfy the equation. Okay, also we can depict that on the unit circle. So let's study how to find all solutions of this equation. Okay, so let's study first cosine x, how to solve or to find all solutions of this equation. Okay, let's depict that on the unit circle. What is meant by an angle? We are looking for x's. X here is an angle. We are looking for all the angles that have the cosine which is equal to a number alpha. Okay, what is a cosine? A cosine on the unit circle is the x coordinate or the y coordinate. Cosine is The x coordinate or the y coordinate? Cosine. Cosine is, we have learned before that for a point moving on a unit circle, the x coordinate is just the cosine of the angle, and the y coordinate is just the sine. Okay? So I'm looking for an angle which has a cosine equal to alpha. A cosine equal to alpha means that its x coordinate is equal to alpha. X coordinate is equal to alpha. Okay? So how many angles do have have this x coordinate? I can look here and I find that this is one of them. This angle, this blue angle is one of them. Also I can find another angle, which is this purple angle, which will also have this x coordinate. So in this case, I may say that I have two basic angles. We have two basic angles which satisfy this equation. These two basic angles are, one of them is the red angle, is the blue angle, which is exactly cosine inverse alpha. This one is just exactly the cosine inverse alpha. What about the other angle? How would I describe that other angle or that purple angle? It just has the same value as the above angle, but in a negative direction. That is in a positive direction. This is a positive direction, and that is in the negative direction. So it is just that angle, but in the negative direction. It is just that angle, but in the negative direction. Okay? So we have two basic angles. One of them is cosine alpha, and the other is the negative of cosine alpha. Each of these angles, we may add to them the multiples of 2 pi. The multiples of 2 pi. That's why we add here 2 pi n. And we add here 2 pi n. What is meant by this 2 pi n? Yes, because any angle, if you add 2 pi to it, any angle, if you add 2 pi to it, it will just give me an equivalent angle. It just give me an equivalent angle. It is just an angle, but an equivalent angle to the first. Okay? This is an equivalent angle. So that's why any of these two basic angles, we add to them multiples of 2 pi, and these multiples may be positive or negative. You may say that you are adding 2 pi n and say that n is equal to 0 plus or minus 1 plus or minus 2, or you may write it as plus or minus 2 pi n and say that n is equal to 0, 1, 2 and so on. Okay? Sometimes it's written in that notation and sometimes it's written in that notation. Okay? So what are the values or what are the solutions? What are the solutions of this equation, cosine x equal to alpha? The solution set, what is meant by solution set? The solution set is the set of all solutions. The set of all, it must contain all solutions, okay? And it doesn't include any number that is not a solution, okay? So it must include all solutions. All of its members are solutions, and it must contain all solutions of the equation. So what are the solution set? We'll find that they are plus or minus cosine inverse alpha plus or minus 2 pi n. Each of these two basic angles, we have two basic angles, then we add to them multiples of 2 pi. Okay? So if I said, for example, I need to solve this equation. I need to solve cosine x is equal to negative 0.3. I need to solve this equation. Okay? I need to solve this equation. So the solution for this equation will be x. We have two basic angles. One of them is cosine plus or minus cosine inverse of negative 0.3. It is plus or minus cosine inverse of negative, then we add 2 pi n. Then we add 2 pi n. Okay? We have, so in summary, we have two basic angles, and each of these two angles we add the multiples of pi n. But we have some special cases for this alpha, for which the expression for the solutions may differ. Let's check these two special cases. These special cases are when cosine x is equal to 0, or when cosine x is equal to 1 or negative 1. The two cases of 1 and negative 1 may be similar to each other, cosine x equal to 1 and cosine x equal to negative 1. Let's check the case of cosine x equal to 0. Or maybe let's check first this one. Cosine x is equal to 1. Cosine x is equal to 1. As you remember, if you remember that to find for a given alpha, this is alpha for example, we just look for these two basic angles. We always have two basic angles, this one and this other one. Okay? If I move this alpha to be 1, this angle and these two basic angles will merge to be one basic angle. Okay? So in the case of cosine x equal to 1, this angle we'll just have one basic angle instead of two. In this case, we'll just have one basic angle instead of two. For a number like this alpha, we'll just have these two angles. But when you move that alpha until it becomes 1, in this case, the two basic angles will merge until they become only one basic angle. So in this case, if you have 1 or negative 1, we will just have one basic angle, which is exactly cosine inverse of 1. So the set of solutions the solution set in this case will just be like that. And what is cosine inverse 1? What is cosine inverse 1? Do you remember? The output of a cosine inverse, or the angle which is cosine inverse, belongs to which quadrant of the 4 quadrants? If you remember. We learned before that a cosine inverse is always in from 0 to pi. And what is from 0 to the output of cosine inverse is always from 0 to pi. And what is in 0 to pi in terms of the quadrants? The first and the second. A cosine inverse is always in the first or the second. Cosine inverse, any angle which is described as a cosine inverse, is in the first or the second quadrants. Okay? So what is cosine inverse 1? It is just 0. Cosine inverse 1 is just 0. So that's why the set of all solutions, we may write it as, or like this, 2 pi n, and we may put plus or minus like this. Okay? But you just need to know that in this case, cosine x is equal to 1, we will have one basic angle. Okay? And similarly for this case, for which cosine x is equal to negative 1, but in this case the angle will be at this side. In this case we will have cosine inverse of negative 1, plus 2 pi n. And in this case this will be just pi. Cosine inverse negative alpha is just pi plus or minus 2 pi n, like this. And this is the set of solution, or the solution set. Okay? So we have learned that for these two cases we have one basic angle. And we add to them 2 pi n. Then we add to them 2 pi n. We add to it 2 pi n. What about this case? Cosine x is equal to 0. Let's depict that on the unit circle. What are the angles that have a cosine equal to 0? We have, in this case, we will have two basic angles, which this one and that other one. This one and that other one. Okay? In this case, we will have two basic angles. Yes, we will have two basic angles, but the difference between them is just pi. In this case, the difference between them will be just pi. That's why instead of having two basic angles and adding to each of them multiples of 2 pi, we will just take one angle of them, we'll just take one angle of them, and then we add pi each time. So we'll just have, originally we had two basic angles, but for this case we may describe them in only one description, which is we'll just have one of them, which is cosine inverse 0, and instead of adding multiples of 2 pi, we'll just add multiples of pi. Why? Because in this case the difference between the two basic angles will be just exactly pi. So in that case, the description of the solution is just easier. We just have one of them and add pi, another pi, and so on. So in this case you will have the set of odd solutions. What is cosine inverse 0? It is just that first angle, which is pi over 2. So in this case it is just pi over 2 plus or minus pi n. Okay? But also in this case, in this special case, we may describe the solution in another way. We have learned this description. This is one description, but also there is another description, which we have done before when we found the domain of tan x. If you remember, when we tried to know the domain of tan x, we have learned that tan x is just sine over cosine. And to find its domain, we have solved the equation for which cosine x is equal to 0 to exclude these values from the domain. Okay? So if you just look at these two angles, which are pi over 2, 3 pi over 2, 5 pi over 2, and so on, and each of these values with a plus or negative values, you will just find a pattern in these angles. What is the pattern in this case? It is just multiples of pi over 2. But any multiples, any integer multiples? No, it is. What is this n? What is the condition in that n? What is the condition of these multiples? It is 1, 3, 5, 7, and so on. What is the condition in this case? N must be odd. Yes, n, we say that n is odd. So this is an equivalent expression for this one. Okay? So, and you have to know the two expressions. You need to know the two expressions for solving this equation. Okay? Okay, let's go on to the next type of trigonometric equations, which is sine x equals alpha. Okay? In this case, let's depict that on the unit circle. In this case, we are looking for some angle x for which its sine is equal to alpha, which means that its y coordinate on the unit circle, its y coordinate will be equal to alpha. Okay, in this case, we will also have two basic angles. What are these two basic angles? We have this angle, this blue angle. This is an angle which has a point which has a y coordinate equal to alpha. And also we have another angle, which is this one. This angle is measured from the positive x-axis. This is the purple angle. So we have theta 1 and we have theta 2. These are the two basic angles of this equation. We have two basic angles which consists the solution of this equation. Okay, what is theta 1? Theta 1 is simply the inverse of alpha. This is the inverse of alpha. Why is it the inverse of alpha? We have learned before that any sine inverse, the output of a sine inverse must be an angle which is from negative pi over 2 to pi over 2. We learned that a sine inverse is always an angle that is from negative pi over 2 to pi over 2. What is an angle that is from negative pi over 2 and pi over 2 with respect to the quadrants? These angles are belongs to which quadrants in the plane? They belong to the first. They belong to, this is the first quadrant, which is from 0 to pi over 2, and we have also that quadrant. Okay, so any sine inverse, any angle that is described as a sine inverse must belong to either the first or the fourth quadrants. Okay, so since we have this blue angle is an angle that has a sine which is equal to alpha, and at the same time it belongs to the first or the fourth, then it is just the sine inverse of that alpha. Okay, now for the second basic angle, which is theta 2, this angle may be expressed in terms of the blue angle. We learned before that any equations to find the whole set of solutions, all solutions are related to the inverse, or solutions are related to the inverse function. Okay, so but we need to find that expression. How to know how to express theta 2 in terms of theta 1, which is sine inverse alpha. This is sine inverse alpha, that blue angle, this is sine inverse alpha. Okay, we'll just notice here that there is, from symmetry, we'll just find another angle. That red angle is just the blue angle in value, but in another direction. Okay, then we'll just find that adding the purple angle with the red angle will just give me pi, or you can see that the purple angle is just a pi. It is just pi. Then going on the opposite direction, in that way, this is the positive direction, the orange is in the positive direction and the black is in the negative direction. Then you are going back in the negative direction with sine inverse alpha. Okay, so this is pi, then going in the negative direction with a sine. So that is the relation between, or these are the two basic angles of this equation. Okay, now both of them we add the multiples of 2 pi. For both of them we add the multiples of 2 pi. Okay, we add the multiples of 2 pi. So for example, if we need to solve this equation, sine x equals to 1 over root 2. Okay, now we learned that we have two basic angles. What are these two basic angles? One basic angle is just the sine inverse of 1 over root 2. Then we add the multiples of 2 pi. Okay, now for the second angle, the second basic angle is just pi minus sine inverse 1 over root 2. Okay, we know that sine inverse 1 over root 2 is just pi over 4. This angle is just pi over 4. So we may express that again to be pi over 4 plus 2 pi n. Okay, now for this one, this is pi over 4. So we have pi minus pi over 4, which will just be 3 pi over 4. It will just be 3 pi over 4. Okay, so these are the two basic angles, and we add the multiples of n pi, the multiples of 2 pi. Okay, so this is the set of equations. We can write the solution set to be pi over 4 plus 2 pi n union with 3 pi over 4 plus 2 pi n, and make it plus or minus as we have noticed before. Okay, so this is the solution set of this equation. But we have an important notice in this case. If I ask you, if I have this angle, for example, Is it better to measure it in this way or to measure it in this way? Okay, is it better to measure it with the black way in the positive direction or in the negative direction like the green way? Mathematically, it is better to express an angle instead of expressing an angle from 0 to 2 pi, a positive angle from 0 to pi. It is better to express the angle in the smallest value, even if it is negative. Even if it is negative, it doesn't matter, the sign doesn't matter with me, but it's better for us to have a smaller value for the angle. That's why it's better to expect the angle to be from negative pi to pi. An angle, it's better to be expressed from negative pi to pi. Okay, how is that? If you have any angle, I just choose the shortest way to express that angle. For example, if I have this angle, that is the best way. No, but this is, if you choose to measure it from the negative side, no, that would not be preferable in this case. It is preferred to measure the angle from the smallest side for it. Okay, for example, if I had this angle, would I measure it like this, or it is better to measure it like this? Yes, it is better to measure it as a negative angle with a smaller value. It is better than a positive angle with a large value. That's why we make it's better to put the basic angles in a form that is from negative pi to pi. Why did I put an open? Why did I make it open in for the negative pi side? Consider this angle. This angle may be expressed as pi, and it may also be expressed from the negative side to be negative pi. So that same angle is just pi, is just equivalent to negative pi. These two angles are equivalent. Now I need just one expression for each angle. So which of them we will choose? We will choose the positive. For this angle only, we'll just choose the positive measure, which that's why we made it open from the negative pi side and closed from the pi side. Okay, why I'm telling you that, let's consider this problem. If I had if I need to solve sine x is equal to negative root 2. Sine x is equal to negative root 2. We learned that theta 1, the first basic angle, is just the inverse. Okay, plus 2 pi n. Okay, and in that case I'll just take the negative outside because the sine inverse is just an odd function. So it will be negative pi over 4 plus or minus 2 pi n. Okay, now for the second basic angle, we learned that it is pi minus sine inverse minus 1 over root 2. Okay, now for this case, we'll just take the minus outside the sine inverse, so it will be pi plus pi over 4. Now this angle is a large angle. Why? Because it's greater than pi. And we learned that it's better to express the basic angles to be from negative pi. So we just look for just an equivalent angle which belongs to that interval. Okay, how would I do that? We just subtract minus 2 pi. We subtract 2 pi from that angle, and in this case it will just be as if we are saying that it is minus pi plus pi over 4. And in this case it will just be minus 3 pi over 4. Okay, so that angle at first it was just pi plus pi over 4. That is a measured angle like this, but we have just chosen to measure it in this way. We have just chosen to measure it from the negative side this way, so that is a better expression for the same angle. Okay, and for that we just add the multiples of 2 pi. So this is the second basic angle and its multiples. Okay, so in this case we'll just say that for in this case we will subtract also 2 pi, which means that in this case it will be minus pi minus sine inverse that value. So we can summarize the solution for sine x equals alpha to be the first angle theta. It is just the inverse of alpha plus 2 pi n. For the second basic angle, it would be pi minus sine inverse alpha, or it would be minus pi minus sine inverse alpha. What would it depend on? It would depend on the value of alpha. If alpha is positive, I will just choose that expression. That will give me an expression for the angle which is from negative pi to pi. And for the other case, when alpha is negative. Okay, so in this case, these are the two expressions for the basic angle depending on the value of alpha. If alpha is positive, then in this case, if alpha is positive like this, in this case we'll just say pi minus sine inverse alpha. But if alpha is negative, so it's better to express the angle as a negative angle. It's better to express the angle as a negative angle. That's why we say that it is negative pi, negative sine or minus sine alpha in this case. And then we add the multiples of 2 pi as usual. Okay, so I've learned how to deal with equations that are in the form of sine x equal to alpha. Okay, now let's go to the special cases for the sine. Special cases for the sine. As we have dealt in the equation of cosine, there will also be 3 special cases. The case for which sine x will be equal to 0, and the case for which sine x is equal to 1, and the case for which sine x is equal to negative 1. These two are just similar to each other, but in this case, for sine x equal to 1, we have learned that before that we have always 2 basic angles, this angle and this one. So when we move alpha to be 1, these 2 basic angles will merge together to be just one basic angle. So in either these 2 cases, we will just have one basic angle. For these 2 cases, for these 2 special cases, we'll just have one basic angle, which is this angle. Okay, so I'll have one basic angle, so the solution set will just be sine inverse 1 plus the multiples of 2 pi. And we know that the sine inverse 1 is just pi over 2. So it is pi over 2 plus 2 pi n like this. Okay, and for the case of sine x equal to negative 1, we will just have a similar case. And for this case, we will just have one basic angle. So the solution may be expressed as sine inverse of that value plus 2 pi n. Okay, what is sine inverse of negative 1? We take the negative outside the sine inverse. Then sine inverse 1, it is just pi over 2 as we have expressed before. So it is negative pi over 2 plus or minus 2 pi n. So these are these two special cases. Okay, what about the case of sine x equal to 0? In this case, we'll just have 2 basic angles, but we will encounter this situation. The 2 basic angles are apart from each other by an angle which is exactly pi. Okay, in a general case, the 2 angles were apart with some angle between them. So we dealt with each basic angle alone or by itself. Then we added 2 pi, multiples of 2 pi for each of them. But in this case, we can consider the solution to take one of them to be the basic angle, and instead of adding multiples of 2 pi, we will add multiples of pi only. So adding 1 pi will just give me that other basic angle, then adding another pi will just give me that one, and so on. So in this case, we will have one basic angle which is sine inverse 0, but in this time we'll just add multiples of, instead of 2 pi, multiples of pi only. So in this case we know that sine inverse 0 is just 0, so the solution in this case will just be plus or minus n pi. A solution of sine x equals 0, it is just plus or minus n pi. Okay, so these are the three special cases of solving an equation which is sine x equal to alpha, and we need to study them carefully and know the differences between each of them. Now let's go on to the third type of equation, which is tan x equal to some number alpha. Okay, now this case, when we have an equation in terms of tan instead of sine and cosine, that is the simplest of them. Why? Because the solution in this case will just be tan inverse of alpha plus multiples of pi. In this case it is the multiples of pi instead of 2 pi. So here we don't have two basic angles. No, in this case, in this type of equation, we'll only have one basic angle. We'll only have one basic angle, which is this, but we add multiples of pi. Why is that? Just remember that we had sketched the tan x curve, which was like this, and the tan x curve had a period of pi. It had a period of pi. Okay, so when I try to find when is tan equal to alpha, we will find infinitely many angles. This one is just the tan inverse of alpha, and we'll have also another angle, which is this one. We have another angle, which is this one, which are apart with an angle just exactly pi. Okay, they are just apart by an angle exactly pi, which is exactly the period of tan x. Okay, so the solution set in this case is just simpler than the previously stated two cases, which are sine and cosine. This case is much simpler than them. It is just you take the inverse and you add up the multiples of pi in this case. Okay, so let's check an example. If I had, for example, this equation, sine squared x minus 3 sine x plus 2 equals to 0. Now, to solve an equation in trigonometric functions, we need two conditions to be satisfied. First, that all the angles are the same. For example, you cannot have, or you cannot start with an equation with, for example, sine to x equal to sine x. This equation are with different angles. So you need first, for an equation like this, you need first to express it in terms of just one angle of them, either all of them to be an angle to x, or all of them to be an angle which is x. Okay, just choose one approach, either this one or that one. Okay, the second condition is to express them all in terms of one trigonometric function. For example, that just like we'll see in another example, I may have, for example, cosine squared x plus sine x equal to 0, for example. Okay, in this case I have two trigonometric functions in the same equation. No, this I can't start an equation like this. We must make all the equation in terms of just one trigonometric function. Either it is sine, make it all in terms of sine, make it all in terms of cosine, or make it all in terms of tan. Okay, either any of these, you may use any of these just to make the equation in just expressed in just one of the trigonometric functions. Okay, so in this equation the two conditions are satisfied. All of the angles are the same, which is x, and we also that the equation is expressed all in terms of sine x. Okay, so we'll start our procedure to solve this equation. This is a quadratic equation which we may factorize like this. So it will be sine x, and 2 and 1, negative, negative, like this. This equation may be divided to be two equations. Either sine x will be equal to 1 or sine x equal to 2 or equal to 1. Let's consider this equation. Sine x to be equal to 2. For sine x to be equal to 2, that is a rejected case. Why it is rejected? Because a sine never exceeds the value of 1. A sine never exceeds the value of 1. So this equation is just rejected. So we'll consider the second equation, which is sine x equal to 1. And we have learned that sine x equal to 1 is one of the special cases that we have learned. In this case, either 1 or negative 1, we have just one basic angle. You just need one basic angle, which will exactly be the sine inverse of that value. And we add up to pi n as usual. Okay? We add up to pi n as usual. Only the case when it was 0, yes, in the case of 0 we had one basic angle, but we added the multiples of n of pi instead of 2 pi. But in the cases of 1 and negative 1, we just take one basic angle and we add up the multiples of 2 pi instead of multiples of 2 pi. Okay, so in this case this is the angle, and which is pi over 2. So the solution in this case will just be pi over 2 plus or minus 2 pi n. Okay, this is the solution set, and here we have no solution, so we have or between them, which is a union. So the solution set will just be this one. So let's check this equation. We have two rules before solving any equation. First, for solving any equation in trigonometric functions, first we must have all angles to be the same. All angles to be the same. Which means I may have not in the same equation cosine to x, for example, and cosine x. No, I need all the angles to be the same. All of them to be cosine x, or all of them to be cosine 2x. All the angles must be first be adjusted to be the same. The second rule is to make all the functions, all trigonometric functions, to be the equation, to express the equation in just one trigonometric function. So you need to express the equation all in terms of cosine, or in terms of sine, or in terms of tan. Okay? You need to express the equation all in terms of just one. So a case like this, doesn't satisfy the second condition. Yes, we have all the angles are the same, all the angles are x. Okay. But what about the second condition, that we need all the functions to be the same? We need all the functions to be the same. So we need all of them either to be all in terms of cosine x, or all the angles or all the functions to be sine x. Which is easier in this case? Should I express that sine in terms of cosine? In this case, if I need to express a sine in terms of cosine, it will just be 1 minus cosine squared x. If I do that, I will just get, and it will be plus or minus also. So I'll just introduce a root inside the equation which was not there. So that is, maybe it would give me a correct answer, but it will be cumbersome for us, or it will be a lengthy solution. But instead of that, we just may express cosine squared in terms of the sine squared, which is known. We know that cosine squared x is just 1 minus sine squared. It is just 1 minus sine squared. So let's substitute that. 3 minus 3 sine x minus 1 minus sine squared x. And we simplify that expression. we will just get sine squared x minus 3 sine x plus 2 equal to 0, and this is exactly the equation that we have solved in the last example. So we have known the solution of this one, which had a solution set equal to pi over 2 plus or minus the multiples of 2 pi. Okay? Let's check that other example. Sine 2x equal to 3 cosine 2x. Now in this case, we have sine 2x equal to 3 cosine 2x. We have here the angles are the same, okay, all in the same equation. We have all the angles are the same. The second condition that you need to express it all in terms of one trigonometric function. We have sine and cosine in this case. But so how to express that in terms of just one trigonometric function? It will be also cumbersome to describe a cosine of in terms of plus or minus 1 minus sine cosine squared. So that will be a lengthy solution. What about dividing the equation by cosine 2x? Let's divide the equation by cosine 2x. We will find that it will be tan 2x equal to 3. Tan 2x will be equal to 3. So you have just managed to express the equation in terms of just one trigonometric function, which is tan. And the equations that are described in tan have an easy solution, which is 2x will be just equal to the inverse plus multiples of pi. So x will be half of these angles. Okay, so this is just the solution set in this case.